Now it's the turn of Andreas Sumper. Peer-to-peer is blockchain the solution. Andreas Sumper is an associate professor at the UPC. He's director of the Endesa Chair of Energy and Innovation at UPC and part of the directive board at CITCEA-UPC. He has over 100 scientific publications and is leading several national and European research projects on digital energy. I give you the floor.
Okay, thank you, Monica. Well, we had a lot of interesting presentations now, and I think everyone has it clear there's a change in the electricity system now, no? Because I think, is there anyone in the room who think that the system will be operated like 10 years ago, in 20 years? Is anyone thinking it will be the things will be the same? I think there's no one. And I raised this question 2 years ago or 3 years ago. There were half the floor was answering, no, well, things will be the same. Now, I think everyone has clear that we are changing, there are things are changing, etc. So I would like to talk to you about a new technology. There's for sure you have heard blockchain as a new technology, and would like to present you a project that we are running at the UPC. This project is a project that has no fund. We are financing itself. There are two very motivated students working with me, which is Greg and Simone, which has contributed to the slide. Greg is here with us now. And I think, and I would like to explain a little bit more about the project. But first, I would like to explain you a little bit why we are here, right? Well, first, we have a digital wind of change. Right? And this is generally, and not only for electricity. Well, and there is, I like very, very much the Michael E. Porter article of Harvard Business Reviews, where he said smart and connected products are changing how value is created for customers, how company competes, and the boundary of competition itself. And this is affecting every industry, and especially the electricity industry, because electricity is a connected product, and electricity is now a commodity. But, well, if we add smartness, we can make it a non-commodity, which is then adding value to the product. Well, value is shifting to the customers. Well, customers have more value in the value chain, and the whole competition is changing. You know, we are talking about local markets, etc. And so we can conclude that the electricity sector is heavily impacted. And why is this happening? Well, we already had some references to what is called prosumers, right? Well, prosumer, what are prosumers? Is a mix of basically the producers and consumers, and their own producers are consuming and itself. Why is this happening? It's happening because the industrial products are mass customized. That means that you can have your connection, your PV panel, you have a converter, you can customize your own household and self-produce or install a battery, and it's very easy. It's plug and play, IoT devices also. So in this sense, in this context, the electricity prosumer, well, is a market participant, and that's why we are here. We are talking about local markets because they are there, they have a potential, right? And for sure they are economically motivated. And they can help the DSO, or they can go against the division of the consumption and of the production. And the digitalization, you can see that this all is happening on the edges of the grid. That means that the DSO, who is located at edges, is the most important player in that. right? So that's very important, right? Sorry for the TCL. Yeah. Well, now we go to the blockchain technology. Everyone heard blockchain. Blockchain is something that will change everything, etc., etc. Let's go define a little bit what is blockchain and how can it help or impact in the electricity sector. Well, blockchain is a buzzword. What is it? It basically is a decentralized internet protocol, right? And it's facilitating transaction between peers, between different computers, without any centralized intermediate institution, right? Okay, well, that sounds really great. Where we know blockchain, it's a core technology of cybercurrencies. It's based on a consensus network. There's a lot of computers, they're connecting together, and they have a consensus about the database or the real transaction it should be made. It is trustless, which is a very important property. Trustless means that there's no trusted entity, there's no central entity like a bank that you have to trust. So, and that means that the whole network, the computer network, creates trust in itself. And it's a public ledger. That means a global, public database where you can write something and no one can alterate what you have written before, right? There's no possible manipulation. Well, how this can match with the electricity sector? Well, the generation and transport distribution is transforming this to a decentralized business. Well, and then there's millions of decentralized generations, small prosumers, smart grid, smart meters are introducing a lot of devices, right? Moving the center of gravity to the edges of the grid. So, well, if we have a decentralized grid, also the ICT system could be decentralized, peer-to-peer, transparent, that there's no possible manipulation, but there's no central entity managing it, and able to, and the most important is we have to able to perform millions of transactions at a minimum cost. Well, what is this looking like? For example, here we have the actual process that we have a really vertical flow from the power plants, grid, to the utility to the customers, where we have like transactions. All the transactions are done over the bank, right? What could be the future process based on blockchain? Well, we will have a common blockchain where a common database where we exchange data, and the electricity flows going over the grid, and there would be a plate trading platform where this data is matched, and then we will the industry or households will be supplied. Well, let's show some examples of possible business models on that. Well, for sure, what we have is, what we need for blockchain is data. Where's the data coming from? Well, from smart meters, IoT devices, sensors, smartphone apps, whatever. Right? And then what can we do? What is a possible business model for that? Well, first we can use cyber currency to pay, right? This is something very, well, normally you can pay with Bitcoins. Well, what can we also do? We can also decentralize the documentation, metering data. We can put metering data in a blockchain, and it's a common database, not centrally organized, it's organized by a lot of computers. Well, also we can secure trade of certificate, and you can know that the certificate is not traded 2 times, for example. And what is most important is, well, maybe the flow of the power, we can manage it with what we call a smart contract. What is a smart contract? This is a contract that is automatically executed in the blockchain, right? Well, let's see what we can, how this will impact on the energy trade. Well, in the energy trade, basically we can have two approaches. Well, we can have a peer-to-peer approach. I want to send to my neighbor some energy. Well, very liberal approach. I can treat with everyone. There's not a problem. Well, we have a contract between individuals. There's like a chaotic power and price matching. That means that maybe I pay to my neighbor more than to the others, etc., etc. Well, on the other side, what we have is a pool approach where we have like a centralized market approach. A centralized can be local or global wholesale market. Well, we need some entity that's running that pool, and there is a clearing price that is managed by an algorithm, or so that we know that we have the cheapest price, cheapest energy will be bought by the loads, but not the most expensive, right? Well, let's see how can be the data exchange, right? Between maybe the power exchange can be peer-to-peer or pool, but let's see what could be the data exchange. Well, peer-to-peer, you know, the first peer-to-peer network was Napster. So we have like users, which are pseudonymous users. We have individual negotiation. But is this really suitable for short-term trading? Not because you have asymmetric market information. Well, maybe your neighbor is offering at a certain price and you have no time to look for more offers. So this is more suitable for long-term contracts. While peer-to-peer platform is like YouTube, where you upload your offer and everyone can consume or not, right? Well, we have registered users. Well, we have one entity like the YouTube provider who knows everything, right? But what you have is here a bigger market. Here's more short-term trading is possible. Well, how we do this, how we implement this at the UPC, where with our students we wanted to make a decentralized wholesale electricity micro-market. For the implementation, we use a very known platform. It's Ethereum. Ethereum is a blockchain platform where you can implement smart contracts. And what we also designed are smart agents, which are based on small computers, Raspberry Pi computers, which have implemented a certain algorithm in order to interact with the Ethereum platform. And what we are focused is in the microgrid market, right? Well, how we have made a simple mechanism. What we do is first we implement a day-ahead market, where we have like the day-ahead. We establish hourly what are the prices. And we make a first round of trading, right? And the different loads and generators are trading. On the other hand, what we once made the day-ahead market, 1 hour before we implement a balancing, it's not a balancing, an intraday market, in order to match mismatches between our load and generation, and to be more accurate of the weather forecast, we are using the 15 minutes time slot, and we can balance those imbalances, right? Well, and then after doing this, we have the real time. Here we execute the smart contracts, and what we do is also we measure the real-time data. For sure, there could be a mismatch between the real-time consumption and the consumption we have traded, and this mismatch has to be provided by a slack. This is a generator that has to provide, or could be a generator, battery. And what we trade is virtual money with cyber currency. What we are called it UPC coin, which is a very innovative name that my students have came up with it. And we want to implement this. We have already some on the computers and the Raspberry Pi. We have already programmed it. But what we would the next step is to implement this. How we have implemented this? We have the Raspberry Pi, where we have which is basically an IoT device. We used a client, which is with Ethereum client, which is parity, right? We create an account for each customers, which is who has a private and a public key. A public key is to identify the account. A private key is to manage this account. What we have is also programmed like the IoT devices. Therefore, we use JavaScript, which is we use the JavaScript API from Ethereum, and also the Node-RED, which is a programming software for IoT devices. We connect via the Modbus to the external world in order to, for example, have measurements of generation, measurements of this smart meters, and to coordinate everything, we use the Power Match suite, right? Well, the next step is, this is working over the table. We have like some Raspberry Pi connecting to the computer, and we are simulating the signals, and we are, from the data point of view, is working. What we are doing in the last step is we want to implement in the same microgrid you have seen before at the UPC, where we have a prosumer lab, where we have a load, battery, and PV, and diesel generator. And with this microgrid, we want to make real measurements of the loads and the generation, establish this market algorithms, and create this local market based on Ethereum blockchain. Well, these are the next step I want to do. In the conclusion of this talk, I want to say that, well, blockchain, you have heard a lot of blockchain. I think blockchain will be one of the technology. It's not the only one technology, but the one of technology will be present in our lives. Blockchain is not like it's solving every problem. It's like internet protocol. It's like HTML 20 years ago. So we can use it for different things. And what we have made here and showed here is something very interesting, because what we did is, well, we take this blockchain, which is a peer-to-peer technology. That means you don't have a central computer system. But what we implement is a pool trading. Because there are several users are going to electricity pool, and they are locally in a microgrid trading electricity, right? So this is a mix of both approaches, which is peer-to-peer from the ICT point of view, and pool from the energy point of view. So both solutions are possible. Also, peer-to-peer exchange is possible in electricity, and that's why blockchain is not necessarily standing for peer-to-peer trading. Well, and last but not least, we're talking a lot about a possibility of blockchain. Well, I think the technology is here. What it's missing are really innovative business models. And this is not, and to use this technology in order to create a very cheap, efficient ICT system, and that's, I think, the most important thing. So there's a need for new business models. Okay, thank you very much. That's all. Hope you enjoyed this.